I am the Tofu Golem. Please enjoy the video.
You start by verifying the charger model and its input/output ratings so you repair with the right parts. Once powered down and unplugged, you remove the enclosure screws and visually inspect PCBs, capacitors, connectors, and fuses. Make sure to photograph wiring and connector orientation. This saves time reassembling. You test fuses with a multimeter continuity check. If a fuse is blown, replace only after confirming the underlying fault to avoid repeated failures. Once done with the initial exam, you power the board via an isolation transformer and measure AC input, DC rails, and standby voltages to isolate the faulty stage. You use the multimeter and an ESR meter to test capacitors, and a diode tester to check rectifiers. Swapping suspected MOSFET on the same footprint confirms switching faults. Make sure to use components with matching voltage, ripple current, and low ESR. Solder carefully to avoid cold joints or lifted pads. You reassemble the charger and first verify no-load outputs, then apply a controlled electronic load to confirm voltage regulation, current limiting, and thermal response under realistic conditions. Monitor for oscillation, rising temperatures, or smell of burning. If all readings are stable, finalize by sealing the enclosure and noting replaced parts. If something still goes wrong, isolate the problematic stage and inject known voltages with a bench PSU to reproduce the fault.
Thanks for watching. Consider subscribing if we helped you today.